In this question we're told that points P and Q are on the x and y axes respectively, and we want to get the coordinates of a point R on the x-axis such that the distance between P and R, or in other words the magnitude of the vector PR, is equal to the distance between Q and R, or in other words the magnitude of the vector QR. Similarly, we're going to try and find the coordinates of a point T on the y-axis such that the magnitude of PT is the magnitude of QT. So here we go. Q is the point 0, -4, and P is the point 7, 0. If we know that R has to be a point on the x-axis, then we know that the coordinates of point R are R0. So the magnitude of the vector PR is going to be the length of this line, which we can see because the y-coordinates remain 0. We can see that the magnitude of this vector would be 7 minus r. Well, 7 minus r is the magnitude of PR. The magnitude of QR is going to be r minus 0 quantity squared plus 0 minus -4 quantity squared, and then that entire quantity square rooted. So what we have is the square root of r squared plus 16. So we see that 7 minus r has to equal the magnitude, or excuse me, has to equal the square root of r squared plus 16. And so we write that out. And at this point, we can simply we can simply square both sides because we don't want to operate with this square root sign here. So we're going to square the left-hand side, square the right-hand side, thereby getting rid of the square root sign. When we expand out 7 minus r times 7 minus r, we get this trinomial equals to r squared plus 16. The r squared terms nicely eliminate themselves, and we end up with 33 equaling 14r, or in other words, r equaling 33 over 14. So the coordinates of point R have to be 33 over 14, comma 0. Next, we look at the point QT. It would appear that the point on the x-axis, we're now doing question B, it would appear that the point on the y-axis T is above the x-axis. And so what we're going to do is say that the distance from T to Q is T plus 4. In other words, T minus -4, or T plus 4. And the distance from P to T, in order to do that, we're going to use the distance formula, 7 minus 0 quantity squared plus 0 minus t quantity squared, square rooted. And so by a similar use of logic, we're going to say that this magnitude has to equal this magnitude, so we can write the equation t plus 4 equals the square root of 49 plus t squared. Again, squaring both sides gives us t plus 4 quantity squared equals 49 plus t squared. When we expand out this, we get t squared plus 8t plus 16 equals 49 plus t squared. The t squared terms nicely eliminate themselves. 8t is 33, or in other words, t is 33 over 8, meaning that the point, the coordinates of point T are 0, 33 over 8.